Exercise 307, finding an unknown angle. Again, we just set up our trig ratio as before. Instead of finding a side, when we find the angle, we've got to use inverse sine, inverse cos, or inverse tan. So, let's look here. Here's my angle. Let's label the sides. I have adjacent, that's next to, and opposite the right angle is the hypotenuse. A and H is car. Cos theta is adjacent over hypotenuse. Cos theta is 8 over 18. Theta is, you know what we do, girls? Cos to the minus 1 of that 8 over 18. Some of you will need to put it in brackets on your calculator, some of you won't. We want this to the nearest degree. So that's what you'll enter on your calculator. Cos to the minus 1 of 8 over 18. See, the instruction is not to put cos of 8 or cos of 18. It's cos of something. Is that? That's when you do cos to the minus 1. What do we get? 60. We need to the nearest degree. You can keep it as a decimal if you want and round it like a decimal number when it's to the nearest degree. Tell me exactly what you see on your calculator. 60? No. Look. If you keep it as a decimal, it looks like that, 63.612, etc., which to the nearest degree would be 64. But if you change that to degrees and minutes, can someone change that to degrees and minutes? So you can keep it as a decimal and you round and say that 0.5 is halfway, it rounds up. If you change it to degrees and minutes, you get... Some of you are in the habit of always going shift DMS and going to degrees, minutes, seconds. If you do go to degrees, minutes, seconds, and you have to round to the nearest degree, 36 minutes is greater than or equal to 30, so you round up the degrees to 64 degrees. But if you're asked to the nearest degree, you actually don't have to convert to degrees, minutes, seconds, because you can just round like you normally do with any number, with a decimal. 0.6 is more than half. That's why you get 36 minutes, which is more than halfway. Okay, the next question. Find this angle. Looks like we don't have adjacent. We've got opposite and we've got the hypotenuse. O and H is so it's sine theta is opposite over hypotenuse. Sine theta is 58 over 92. And so theta is sine to the minus 1 of 58 over 92, which is 39.08. You don't have to change it to degrees, minutes and seconds. That would just be 39 degrees to the nearest degree. But if you did change it to degrees, minutes, seconds, did anyone change it to degrees, minutes, seconds? When you tell me what you did get if you do DMS. 4 minutes? So 4 minutes. See how 4 minutes is less than 30 minutes? So it's just 39 degrees. Okay, just continuing with question 6. A plane reached a height of 171 metres after flying 500 metres in a straight line. So the plane will be going like this. And it flew 500 metres in a straight line, and the plane reached a height of 171 metres. So I can draw a right angle triangle here. So a plane reached the height, so the plane will start here and end up here. The plane reached a height of 171 metres after flying 500 metres in a straight line, and at what angle to the horizontal was the plane flying? So we're working out this angle over here. Okay, so we can see if this is my angle theta, that this is the opposite side and this is the hypotenuse. So I'll use sine theta is opposite over hypotenuse. So sine theta is 171 over 500. So theta will be sine to the minus 1 of 171 over 500. And just working that out. 19.998, so to the nearest degree, this would be 20 degrees. Look, I haven't changed this into degrees and minutes because they just want it rounded to the nearest degree. But if I do change it to degrees and minutes, So if I do change it to degrees and minutes, that's what I get. 19 degrees, 59 minutes, 55, or really basically 56 seconds. So that rounds up to 19 degrees, 60 minutes, which is just 20 degrees basically. So you can see that it's actually easier if you're rounding to the nearest degree to just keep it as a decimal, because you're really just rounding it to the nearest whole number. So 19.998 degrees rounds to 20 degrees. Okay, now in the next question, we're finding the pitch of this roof. So we're finding this angle theta. So I'm just going to draw another right angle triangle here. Okay, now if this distance here is 3.4, you can work this one out here by subtraction. So 3.4 minus 2.7 is 0.7. And if this is a house, and if this is like an isosceles triangle up here, and this is 7.8, we're going to assume that this distance across the bottom here is halved. So I need to do 7.8 divided by 2, which is 3.9. So the two calculations I did, we did 3.4 for that height minus 2.7, and we got 0.7 meters for this little section here. And for this section here, we got 3.9. So we're working out the pitch of the roof there. So we've got the opposite side and the adjacent side. We do not have the hypotenuse, so we'll be using tan. So tan theta is opposite over adjacent. So tan theta is 0.7 over 3.9. And theta is tan to the minus 1 of 0.7 over 3.9. Which is asked to find this to the nearest degree. So I would just round from the whole number, 10.1755, rounds to 10 degrees to the nearest degree. But if I was to change that to degrees and minutes on my calculator, I get 10 degrees, 10 minutes, 31 seconds, which really rounds 10 degrees. This 10 is less, so 10 degrees, 10 minutes. This 10 is less than 30, so it still is 10 degrees. But when rounding to the nearest degree, honestly, it is much easier not to change it to degrees and minutes. Question 11. A hill has a gradient of 2 over 15. Now remember that gradient is rise over run. So remember, gradient is rise over run. So if the gradient's 2 over 15, it rises 2 for every 15 run, or we could have gone rise to 15 run, okay? So, which means that it rises 2 meters for every 15 meters horizontally. So 15 meters horizontally, 2 meter rise. The question is to find the angle that the hill makes with the horizontal. So here's the horizontal, we have to find this angle here. So here we've got opposite compared to the angle and adjacent, so we will use tan. So tan theta is opposite over adjacent. So tan theta, our opposite is 2 and our adjacent is 15. So therefore theta is tan to the minus 1 of 2 over 15. And entering that on your calculator, we get 7.5946 whatever degrees. But we have to round this to the nearest minute. So we're going to put this in degrees and minutes. We get 7 degrees, 35 minutes, 40.72 seconds. Now, so I've got 7 degrees, and I have to decide, is this going to stay at 35 minutes, or do I round it up to 36 minutes? So I need to look at what's at the second. So remember, I've got degrees, minutes, seconds, degrees, minutes, and seconds. So 35 minutes. Let's look at the seconds. I've got a bit more than 40 seconds because it's 40.72 seconds, which is bigger than 30 seconds. So therefore, I have to round up the minutes to 36 minutes. So it's 7 degrees, 36 minutes. Okay, that's the end of that. That's the end of those examples for exercise 3.07, finding an unknown angle. Okay.